Hi, PreCal. It is Ms. Kosh, and today we're going to go through the inverse notes. This is, I think, 1D/E. Okay. So a few things about inverses. An inverse will undo the other function. So like if you want to undo addition, you use subtraction. If you want to undo multiplication, you use division. If you want to undo squaring something, you take the square root, etc. There's more. If you want to undo the square root, then you square both sides, or square this. There ends up being a square in this situation. So they kind of undo each operation. The next thing, the x and y switch when finding, so what is x in the original becomes y in the inverse. The domain in the input values, what is the domain in the original becomes the range in the inverse. What was the range in the original becomes the domain in the inverse. So those things, everything x and y, they switch. It's also something, it's been reflected over the line y equals x. Okay, so what we're going to find is that just because you have a function, it doesn't mean its inverse is necessarily a function. But our notation matters, and I was noticing on these notes there were a couple things I want to tweak. First of all, if I have, let me show you what I'm talking about. If I look at the graph y equals x squared, my function looks something like this. Well, when I switch things, then what we will end up with is if we reflect everything over the line y equals x, then now we've got something that's going like this. This is not a function. This piece right here fails the vertical line test. So what we'll do is we'll come back to the original and restrict the domain. We'll say we just want this positive piece of the graph so that now when I take the inverse right here, pretend I drew correctly, here's the line it reflected over. When I take this inverse, this is now still a function. Okay, so what we will do is this notation, if I'm looking for f, if I give you f of x is equal to x squared, and I'm asking for the inverse, it's f to the -1 of x, it becomes, this is function notation. So whatever you write next has to be a function. If I came over here and switched x and y, and then I went square root, plus minus, my y is equal to plus or minus root x. And so this part right here is the square root of x. This part is equal to the negative square root of x. It's okay for y to be equal to something that's not a function, but it's not okay to use function notation to equal something that's not a function. And so in this world, when they say find the inverse of f, they are assuming that you have restricted wherever you needed to restrict so that this answer is a function, and we're going to restrict it to the positive piece. Okay, hopefully that makes sense. We'll practice more as we get going. Okay, so, and we can use the composition of functions, f of g of x and g of f of x, they both need to equal x in order for two functions to be inverses of each other. So on this one, we're going to find the inverse of the graph y equals, or f of x equals 2x plus 4. So I know that I have a y-intercept 1, 2, 3, 4, and a slope of 2. Y'all, my eyes are not as good as they were a few years ago. I think over there we go. Is that, no, I did it wrong. Dang it. I think this should be here and this should be here. I'm so sorry. Okay, so here's my line. That's embarrassing. Okay, and then, well, so here, let's do it this way. If I have x and then 2x plus 4, let's go -2, -1, 0, 1, and 2. When I plug this in, -2, that's -4, that gives me 0. This is going to have a slope of 2, so we're going to go up by 2. So this is 2, just verify. 2 times -1 is -2 plus 4 is 2. Here, this gives us 4, this gives us 6, this gives us 8. And so now when I switch, in order to find the inverse, I'm going to switch these. So my new equation, the new x values will be 0, 2, 4, 8, and 6. And their corresponding y values will be -2, -1, 0, 1, and 2. We have switched our x and y's. Let's see. 0, -2. Then I have 2, -1. Then I have 1, am I right? 1, 2, 3, 4. 5, 6, I should be here. 7, 8, I should be here. Okay, and this graph should be a reflection over the line y equals x. Okay, graph both. Then they want us also to find the inverse. So I'm going to switch x and y and solve. So I'm going to subtract x minus 4 is equal to 2y. And now I'm going to divide by 1/2, divide everybody by 1/2, and so I get 1/2 x minus 2 is equal to y. Let's see, this has a y-intercept of -2. Sure enough, that's what we graphed a second ago. And a slope of 1/2, up 1 over 2, up 1 over 2, up 1 over 2. And here is that new graph. So the inverse, we could say it this way. The inverse of f is equal to 1/2 x minus 2. Okay, so on this next one, I am using another teacher's notes, which is very wonderful and great. But they had written, is f of x a function? Well, by definition, f of x is a function. It doesn't even matter what you've drawn here. And so I'm going to change the wording on this worksheet to say the graph a function? Is the inverse a function? Okay, and so with this one, we've got a little piece. This looks to me like a little piece of a square root curve. And I see, well, y'all, I hate to admit it, I'm finding my reading glasses. I'm in a state of denial. Not so much, I bought the reading glasses, but I don't like to wear them, and I definitely don't like to wear them at school. Okay, but I kind of, oh, and now they're really dirty. Lovely. Okay, so on this one, I see the point 0, 1, 2, 3, 4, 5. So I'm going to plot the point 1, 2, 3, 4, 5, 0. So this one was the point 0, 5. And what I'm doing now is I'm now plotting the point 5, 0. And then this is the point 1, 4. So now I want the point 4, 1. Okay, and then let's find, this seems to be the point right here of 1, 2, 3, 4, 1, 2, 4, 1, 2, 3. So I need 3. So this point, did you see what I said? This is the point 4, 3. So now I need the point 1, 2, 3, 1, 2, 3, 4. So this becomes, oh, it's still growing. Oh, that's terrible. Okay, anyway, it's somewhere in between here. And there's a piece of that graph. If this has an arrow, that would have an arrow. Okay, something like that. Is the original graph a function? Yes. Is the inverse a function? Yes. So notice this would pass a vertical line test. I didn't draw it very well, but it was kind of tricky to do, not going to lie. The domain of this is going to go from 0 to infinity. Oh, no, it's a hard bracket. We included that point. Oh, my. And then I go to positive infinity. What is the range? Well, we had all these, we would go from negative infinity, work our way up to this maximum value of 5. So it's negative infinity to 5. Well, with this graph, what's our domain? Our domain was negative infinity to this x value of 5. And our range was 0 is the smallest value, and then we go up. Here's what we need to notice. These match, and these match. Okay, so far so good. Let's keep going. On this one, they want us to use the composition of functions to determine if the following functions are inverses. And so I need to see f of g of x, which would be equal to f is 3 times something minus 1. The something is 1/3 x plus 1/3. 3 times 1/3 is just 1x. 3 times 1/3 is 1. And this equals x. So far so good. We can keep going. Now let's do g of f of x. G of x is 1/3 times something plus 1/3. The something that we're plugging in is 3x minus 1. Distribute. 1/3 of 3 is just 1, so 1x. This is minus 1/3. This is plus 1/3. Well, minus 1/3 plus 1/3 equals x. And so, yes, both of these, both f of g of x and g of f of x, cleaned up to equal x. And so these are inverse functions. Let's try this one. F of g of x would be equal to 3 times, anyway, I'm not saving space very nicely. What do I need to plug in here? Negative 1/3 x plus 1. When I distribute, I see a negative x and a positive 3, and then there's still, I'm not distributing anymore. Sorry for that notation. This 3 went to here and to here, and then I just wrote plus 3 down. This gives me a negative x plus 6. Nope, not inverses. And once I see that one of them doesn't work, there's no need to do the other side. Okay, so now here we are with this one. This one here, this is going to get a little tricky. We have a parabola. And so our parabola is going to have a vertex. It's going to be, it was shifted over to, you know what? No, I guess maybe, and down 5. 1, 2, 3, 4, 5. I don't know why I wrote that little dot. I shouldn't have. So here's the vertex, and then I'm going to go over 1, up 1, over 1, up 1, over 2, up 4. 1, 2, 3, 4. Back to 1, 2, up 1, 2, 3, 4. And then let's go 3. 1, 2, 3, and 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the other one is going to be on this same level and one more. I think it's here. And so here's my lovely little parabola. This passes a vertical line test, but we can tell if its inverse will be a function by does it pass a horizontal line test? And the answer is no. So what we're going to have to do is we're going to have to, the domain of f as it's written is negative infinity to positive infinity, but that will not match the range of the function here. Because they're making us use this one, to find the inverse, it's a function, we have to only use we have to use one arm of this graph. Okay, so let's look at this for a second. We're going to switch x and y. I'm going to add 5. I'm going to square root. And I'm not going to do the plus or minus, because if I do plus or minus like the cheer, then I would have something that's not a function. I would have the plus part and the minus part, and that would give me something that's not a function. Now I'm going to subtract 2, and so my f, the inverse of f, will be the square root of x plus 5 minus 2. And notice, be careful that that minus 2 has to live outside the radical. And so we're going to find that this is going to shift me left 5 and down 2. So 1, 2, 3, 4, 5, and down 1, 2. And then I'm going to go over, I'm going to go over 1 and up 1. I'm going to go over 1, 2, 3, 4, and up 1, 2. So there's that point, and I want this piece of that curve. Okay, this, the original function, it had a range. It went as low as negative 5, and then it goes up to infinity. The domain here, you'll notice the smallest x value I had was negative 5, and I go to positive infinity. But my range does not match this, because if I did match that range, I wouldn't be a function. And this is saying the inverse function has to be a function. And so this is going to go as low. How low does it go? Negative 2 to infinity. Okay. The next one, on this one, we're starting with, oh, we have a negative 2. All right. I'm going to shift my graph. You know what? Let's see. I'm just going cross-eyed with all these lines. Let's say we're gonna make each line worth half. So this is 1, this is 2, this is negative 3, here's negative 4. Okay, and here's positive 1. That's not positive. That's negative. Negative 1, positive 1, positive 2, positive 3, positive 4. I'm just gonna scale this out a little bit. I haven't worked this problem yet. This might be a bad decision. We're about to find out. Okay, so these are the values that we care about. These are the whole numbers. Okay, so I'm going to shift left 3, 1, 2, 3, and down 4. 1, 2, 3, 4. I think I'm here. 1, 2, 3. Yep, 4. Okay. And so then I'm going to go, oh, that was a bad decision. Instead, I'm going to go to the right one, but I'm going to go down 1, 2. So I'm here. And it's going to be growing something like that. I'm sorry, I should draw that one again. But basically what happens here in my table, if I plug in negative, so here's my x, and here's my negative 2 times the square root of x plus 3 minus 4. When I plug in, we know that we're starting here at negative 3. Negative 3 plus 3 is 0, so the square root of that 0, so this just becomes negative 4, which we had. Now let's go over 1. So let's plug in a negative 2. Negative 2 plus 3 is 1. Square root of 1 is 1. Negative 2 minus 4 is negative 6. Okay, now let's plug in, let's go over 4 from here. So let's plug in a positive 1. 1 plus 3 is 4. Square root of 4 is 2. Negative 2 times 2 is negative 4, and another negative 4 is a negative 8. And so those are some of the points of that graph. And so it's looking something like this. You didn't really have to do that. I just felt bad that I took us off the grid. Okay, so now let's find the inverse. So this x is equal to -2 times the square root of y plus 3 minus 4. I'm going to add 4 and divide by -2. And now I'm going to square both sides. I'm running out of room. I'm going to say -1/2 times x plus 4, and this whole thing gets squared, and it equals y plus 3. So this was still inside here. Yeah, I added 4, I divided, and then I can, okay. And so now I'm going to subtract, and I'm going to say I'm going to say the inverse of f is equal to -1/2 times x plus 4, close those parentheses, squared, minus 3. Oh my, here's that answer. What a mess. Okay, what's the domain? Well, the domain here, typically a square, a quadratic has a domain of all reals. However, we need, I lied to you. This, I'm looking at the wrong one. The domain, how low did we go? We went to -3. I didn't mean to lie to you, it just happened. And then here we went as high up as -4, and so we're gonna go from -infinity to -4. And on this one, okay, so now the inverse, we think, a quadratic has an inverse of, a quadratic has a domain of all reals. However, this quadratic is not standing alone. This quadratic comes from this piece right here. And so what we have to do is we have to switch the x and y. So we need the point -4, -3 right here. And then we need the point -2, -6. -2, -6 is going to be 1, 2, 3, 4, 5, 6, -2. So we're already down here. And so I did that backwards. -4, -3, and now we need -6. It's over here, -2. And so we're looking at this piece of the curve, and so it reflected over that line. Oh, that was terrible. Do you know what? I'm going to make a desmos explanation to clean this up and just show you on the screen. But basically what happens is this domain has to be, the domain has to match what we saw in the range a minute ago, -infinity to -4. And the range is going to match this one right here. And I'm stopping this video, and I'm going to make a video on my iPad where I'm doing this exact problem. I'm going to show you these two on Desmos, and everything will be clearer. So go look for that video and watch it. And then like, subscribe, comment, let me know how I can help you. And the only way to learn math is to practice. So guess what you have to do? You have to go practice. Good luck.